Hello friends, welcome back to my YouTube channel. This is Assistant Professor Amdas Pandit Bharsar. In this video lecture, we are going to study about titrations curves, or we can say nature of the titrations curve. So before going to study, we should know what is meant by pH. So the pH is the negative logarithm of hydrogen ion concentrations. Okay, and the formula for the pH is pH is equals to negative logarithm of hydrogen ion concentration. Okay, now for that we should know pH range, or we can say its scale. So in front of you, you can see here pH range having 1 to 14. Okay, 1 to 14. So in that, those solutions having pH 7, so we call them neutral. Okay, for example, you can take salts, or sodium chloride is a best example. Okay, now less than 7, those solutions having less than 7 pH, we call them acids, or a acidic condition is there. Okay, so the examples are, you can see hydrochloric acid, sulfuric acid, and acetic acid, and etc. Okay, so acids having less than 7 pH. Okay, and more than 7, we call them basic solution. Okay, examples, you can take sodium hydroxide, ammonium hydroxide, and etc. Examples we can take in a basic or bases which having the more than 7 pH, which is from here to here. Okay, now we have to see the first type of titration curve, that is, you can see titration of a strong acid and strong base. Now let us consider the titration between HCl and NaOH. Okay, now HCl is having less than 7 pH and NaOH having more than 7 pH. So HCl is in a acidic state and NaOH is in a basic state. And in this titration, HCl is a strong acid and NaOH is a strong base. And one more thing, HCl we can use as a titrant and NaOH is used as a titrant. So the 25 ml of zero point 0.1 normal HCl you can take in a conical flask by pipette. Okay, and the NaOH you can fill into the burette. And we know that the HCl is a acidic. That means the pH will be less than 7. And you will see the concentration of HCl, that is zero point 0.1 normal. So you can conclude from this pH of HCl will be near about 1. That means if you will add the base, that is NaOH, into the HCl, so what will happen? pH will be increase. In this way, you can see, okay, at first stage HCl we have taken, that is 25 ml. Okay, and here the pH will be 1, near about 1, and when you are adding the NaOH, so the pH will be increases slightly. Okay, like this. And when you are adding near about 24 or 25 ml into the this 25 ml of zero point 0.1 normal HCl, so what will happen? The pH is increases. Okay, in this way, like this. And in this titration, if you are using different kinds of indicator, that we have no, they have different transition range. So between this transition range, this pH curve going. Okay, now we have to see the main characteristics of these uh, titration curves. Okay, this is titration curve. In this case, the first point is when you are adding base into that acid, so at the starting is that solution pH will be 1 when we are without addition of base into that solution, the pH will be 1. The next point is there is a steady and linear increase in pH with the addition of NaOH up to the 24.5 ml. Yes. In this solution, 25 ml of zero point 0.1 normal HCl, that when you are adding the NaOH, zero point 0.1 normal NaOH, so that times initially that curves is steady and linear. Okay, increases up to the addition of 24.5 ml solution of base. Okay, in this way you can see it bends upward in the volume range between 24.8 to 24.95 ml. When you are adding the base that much amount, that times you will see here the bends upward directions. Okay, and there is a sharp and large linear change. You can see here sharp and large linear change in pH in the volume range between this 24.98 to 25.2 ml, and the pH change near the equivalence point covers approximately 3 to 10 pH units. You can see here from this indicator to, to this indicator. This is the transition range between 3 to 10 pH units. And you can see between here will be the equivalence point, that is approximately between this range, pH transition range. So it bends downward in the volume range 25.5 ml or 25.15 ml. When you are added that much amount solution, that is NaOH, okay, 25 ml, okay, to 25.15 ml. When you are adding this that much amount of base into the acid, that times you will get this kind of bent titration curves. Now in this titration we have to determine which indicator is the best, and we have know the transition range of all indicators. From that transition range we have to identify now which one is the best indicator. Okay, between the transition range 3 to 10, you can see in this way the pH change around the equivalence point, that will be obviously 3 to 10 pH unit, and we have the pH at equivalence point, that is 7. Okay, and we know the transition range of all indicators, that is methyl orange having 3.1 to 4.4, okay, and methyl red having 4.2 to 6.3, and bromothymol blue having 6 to 7.6, and phenolphthalein indicator having 8.3 to 10 pH transition range. Okay, so you can see the pH equivalence point is 7, in which transition range is going to fix. You can see here. So simply you can identify the 7, that digit is come into the 6 to 7.6, that is the bromothymol blue is the best indicator for this kind of titration, that is strong acid and strong base. Okay, so in this way the equivalence point in this titration, bromothymol blue This indicator can show their complete reaction. And in this way, when you are adding base into the acid, that times the pH going increases like this. When you are added any OH added ml 2.25 ml, so that time you will get 1.08 pH of that whole solution. So in this way, when you are adding NaOH 25 ml into the HCl of 25 ml, so the time that solution the pH will be 7. That is the equivalence point of that titration. Okay. And when you are adding 26 ml of NaOH into the HCl, that times the pH will be whole solution 11.29.